Welcome to Advanced React. Jag heter Sinisa. Jag kommer från Serbien. Men jag vill tala engelska. I already presented myself, actually. I'm a consultant, instructor. I'm external lecturer at DTU and ITU, where I teach several courses, including frameworks and architectures for the web, which actually my talk is, let's say, from this area. Before, I was associate professor at University of Belgrade, and I have also extensive experience as a software architect and developer. About React, I believe that you know already about that. Just a few words, that it is one of the most popular web front-end frameworks, developed and maintained by Facebook, and used by many other companies, including major brands. It is compatible with many other application frameworks and patterns, like Redux, Bobex, RxJS, Block, Xstate, and so on. It supports both client and server-side rendering, which means it's SEO-friendly. It has a, let's say, version for mobile development, which is called React Native. Has a large community and large ecosystem, a lot of external frameworks. Basic concepts are easy to understand. It's a declarative, component-based, with functional approach. And here is a small functional component which actually greets someone and generate this h1 tag, HTML tag. But there are a number of various concepts, features, caveats, which actually prevents us to really fully exploit React. As I think it's saying, is devil is in details. So we have to know these details actually in order to really master the React development. So there are class and functional components, properties, states, mutable, immutable state, React hooks, higher order components, virtual DOM, unidirectional flow, and so on. So many different concepts. And then there are also some, some strange things that you have to take care of, some rules, constraints, and so on. For example, if you want to use so-called useState hook, then calls are allowed only at the top level in the function body and must be always in the same order called, and so on. So some, let's say, little bit strange rules. And to really completely grasp and exploit full React potential, I think one needs to know, first of all, fundamental software architectural concepts, general one, regardless, independent from React, and then also underlying architectural principles of React. And that's why one of these fundamental concepts is the concept of state. And that is the main subject of my today's talk. And using this state, I will actually explain, for example, this weird hook rule, why it is so. And then, of course, if you understand this, then it is easy to remember and easy to follow, and you have no problem then to use in such way. So my main topics in my talk are: what is the state and why do we need it? Some short theoretical foundations. Then what is the React approach to the problem of state management? I will talk a little bit about functional stateful components and this mentioned useState hook. Then importance of immutable state. And then I will explain actually this weird useState hook rules and what are the consequences if we not respect them or not follow these rules. And then at the end, very shortly, I will say a few words about React courses which are given by Lund&Bendsen. So, what is the state? Well, any software system can be formally defined as a black box which transforms inputs to outputs. However, we cannot define and implement the system as a simple mathematical function, because for the same input, output can be different at different time moments. Why? Because output depends not only on the input, but also on the system's history, what happened before. And one possible solution how we can do this is that we provide all previous inputs in addition to the current input, and then we could generate new output of the system. It is not efficient in many situations, but it is used sometimes, and actually even sourcing pattern is essentially based on this idea. Another possible solution is to introduce the concept of state. And the state can be very informally but very precisely defined as a set of information about the past and the present of the system that is sufficient to determine its future outputs, assuming that future inputs are given. And having in mind this idea and view, then the whole system can be represented as a composition of two functions. The first one called state transition function, which basically translates the input and previous state to the new state. And then the second function is so-called output transformation function, which then transforms the state to the output. And this small diagram illustrates this idea. So that is, let's say, this theoretical foundation, how you can any software system perceive. But what is the React approach? First of all, React has no ambition to cover everything. The architectural role of React is actually to cover the output transformation, which is basically what is called in React terminology rendering, user interface rendering, and also formation of the inputs, events, and user interface forms that user can, of course, enter data and, of course, can then invoke events and so on. So React actually has no ambition, and it is unopinionated or tolerant regarding how the state itself is realized and how application state is structured or represented or whatever. And can be any architectural pattern. It can be Redux, it can be MobX, it can be reactive JS, can be block, can be Xstate, can be any other. So in that case, React sometimes is called a library, not a framework, because it does not actually impose the architecture of the whole system, but just parts of the system which is related to this rendering or generation of the interface and of course enabling input and so on. And React has actually this so-called unidirectional data flow. So the state is translated, transformed to the user interface. From user interface, events are generated, and then from events you change the state. So there is no direct connection between user interface and state, which is, let's say, one distinct characteristic of React, comparing, for example, to Angular. Extra benefit of this approach is actually that server-side rendering is possible, because you can decouple the output transformation from this state and how the state is maintained and so on. It can be on the server side, which is, of course, one issue, as you know, because of these search engines and so on. Very briefly, user interface in React, of course, is composed of components. There are two types of components, so-called class and functional components. And complete user interface is rendered as a composition of rendering these nested components. So it's actually, whole interface is considered as a tree consisting of components, and each component has its own rendering, and actually the whole output is then, let's say, consisting of these nested components and the way how they are rendered. So the global application state is mapped to the properties of components, and then from these properties, then of course user interface is generated. But components sometimes need to have its own state. These are called stateful components. For example, to keep values entered by users. And please note, this state of the components is different from the global application state, so it is not the same thing. Class components are basically objects with state. But there are several caveats, specifics, which you have to take care that, for example, you cannot really use this state property to directly change the state, and you cannot always rely on the value of the state because of the asynchronous nature of React, so you have to use some callback functions and so on. So there are issues here how you can really use these objects or class components. But this is not topic for today because I don't have enough time to go into these details here. What I am actually going to talk more is about stateful functional components. Actually, how can functions have state? It is a little bit strange because functions are, pure functions. They transform properties to the user interface. And the problem of this stateful functional components is actually solved in React version 16.8 with the introduction of so-called hooks. And there is a special useState hook which enables functional components to have state. So nowadays, React can be purely functional. Before, because of these class components, it was a mixture of object-oriented and functional approach. Of course, class components still exist, so you are free to use them. But if you prefer to be fully functional, then you can nowadays do so. So, to understand this useState hook, let's remind again that usual functional approach how to handle the state is basically that the function takes the input and the current state and creates the output and the new state. So that is actually how you deal with the states. Here it is important to understand that states are immutable, which means that new state is completely new state, independent from the old state. They are two different structures. And here, in this approach, there are two main problems. First of all, how to keep and protect the state, because the state is out of the function, and it is output of the function. So who holds this state, who creates this state, how you protect this state, and so on. And the second thing, the second issue is how to create a new state from the input state regarding this immutability. And the problem one, keeping and protecting state, of course you can say it's not my problem, that is the caller's problem. He has to take care about how the state is kept and protected and so on, but of course it is not a real solution. So React solution answer to that problem was to have this useState hook, which is function used to create, keep, and protect the state. And this function, actually when you call it, returns two things, two values: the current state and the function that updates the state. So here is some small example, which is some fragment of the user interface where you can click on the button, and then you can see how many times you clicked on the button. And so it is a function, all right? And because we need this state, how many times we clicked, we need this information to keep somewhere. That's why we call this use state hook, which is a function. We provide initial value, in this case the counter, how many times I clicked, which is initially 0. And then I got these two values, count, the value of the state, and function set count. And then I render the interface, how it should look like. It should have this text. You clicked how many times, which is the value of the state. And then, of course, on the button, I have event handler, which actually change the state by increasing the current count. So that is the way actually how you achieve that functional component function can have a state. The second problem, creating new state from the input state. There is an issue here regarding this immutability in the case when you have deeply nested objects. In JavaScript, there is a so-called spread operator, which enables you to do so-called structural sharing, that you can basically copy some object, and that's way how you can create a new one, and then you update this new one. But the issue is that this copying is actually shallow copy. So in case that you have a deeper structure, then basically these input and output states share some objects, and then when you update one, then you can actually update the other one as well, which is not allowed. And for that, of course, you can use, there are some external libraries like Immutable or Immer, which enables you that transparently you can change, and then this library will handle all of these issues. But in some situations, it is too heavy to have external libraries. You have more dependencies, extra learning, and so on. And the React solution for that is actually that we can decompose the object and have separate state variables for each object fragment or part. And then we can use use state hook several times for each state variable for each object fragment. So here, for example, I had in my state, I had some object with properties name, John, and then contact which is object consisting of email and phone. And then when I use this spread operator, I will get a new state. However, if I change the email of the contact, then actually in the same time I will change the contact in the old state, which is a problem. So I can solve this problem by decomposing object into two states, basically, for each part, so that I have one state for the name and the other state for the contact. And then I can use, of course, this spread operator, and then I can change this email, and then, of course, the new state is changed, but old state will not be changed. So basically, the bottom line is that you can have several states within the functional component, which means that you have to call this use state hook several times each time for each this let's say state component. However, there are some rules which say calling hooks is allowed only at the top level of the function body. It is not allowed that you put this use hook inside some other statement, like if or while or something like that. And they can always be in the same order. So why such rules? Because actually React identifies internally each particular state variable with the sequence number of each use state call. And then it keeps all these state variables in an array and use this call sequence number as index. So when you 3 times call some use state, it keep all these states in an array. However, if you use calls this use state hook inside some other statement like if statement, and then if the condition is true, you will actually call, for example, you have a person, and then person is married or not married, and then depending on that you can have another component property dispose of the person, and then you put it under if statement, that if person is married, then you have this suppose property, otherwise you don't. And then in the first case, if it is true, you have actually this index created with the 3 elements. However, if it is false, then of course, because of the if statement is false, then the second call is omitted, skipped, and then you call the this address, for example, component, but actually React will understand this as the second part. And then actually you will mix up the states of the suppose and address and so on. So that is the actually underlying situation why these hooks actually has such rules. So this is an example, for example, some minor details which, if you are not aware of that, can have big problems. Of course, there are React development tools which can detect and report this an error. But of course, it is always good to know fundamental reasons and what are the consequences if you don't respect such rules and consequences. And at the end of my talk, I will just shortly say that here at Lund&Bendsen there are offered courses regarding React. The first one is called Advanced React, which basically provides a deep understanding of React framework, and it is for developers with have some practical experience with React, but are interested, of course, to acquire a deeper understanding of the frameworks, to understand all of these details regarding not only functional components but class components and many other things. And then the second course, which is in preparation still, called Building Advanced Web Apps and Using React and its Ecosystem, is actually discussing some wider issues regarding the application architecture, possible solutions, architectural patterns in building web apps, for example, global application state management, data entry, validation, asynchronous fetching, caching, and updating server data. Here was a discussion, for example, about caching. And of course, it will be introduction and presentation details of some external React frameworks which deal with these issues. And of course, it is for developers which have already solid understanding of React, but are interested to become really proficient in solving all these most demanding challenges in building advanced web applications. So, questions? Do we have time for questions?
Yeah, quick ones. Yeah, quick ones. Nobody?
Why would you have 3 lines with use state in a row? I mean, it's only the latest state that you normally use.
This is you have a current state which you decompose into substates. So actually your state, which is a single entity, because of these issues with immutability, you actually then decompose. And then for each part you have a separate call for this use state hook. So it is basically needed if your if your component needs a state which is deeply nested. But in many situations, because it is user interface and it is a state of component, in many situations is actually you don't have really so deeply nested state. So in many situations, it's okay to just have one single call. But sometimes you need this. Tack för idag.